All right, so once again, the intention of this video is to give you a little thing you can refer back to in terms of how to do assignment 2. Because assignment 2, just like the stuff you will be dealing with at work, has a number of different dimensions, right? It's kind of a matter of judgment how you're going to do it. And hopefully you guys are out there, you're studying the job ads, and you're going to see a lot of job ads these days actually talk about. They say we want candidates who are comfortable dealing with ambiguous and vaguely defined project requirements. That's a polite way of saying the company knows that they don't really know what you're supposed to do. They want you to figure it out by yourself. So the ability to create structure and structure your own work is something that we as professional people do. And it's what you're going to be doing here now. So we said the key learning outcomes for this activity: how to do quality assurance engineering in software project construction. So you are going to, in this project, in this activity, specify in the software specification portion of your activity, you're going to specify what your project is. And you don't have to code the project, so if you want to be ambitious and say you want to make Uber or Netflix or something, go for it. What your project is intended to do. So, for example, suppose and I don't want to give examples because I don't want you to do what I'm saying. I want you to come up with your own idea. But suppose I wanted to develop a project to, I know it's kind of a cliche. Everybody does this for capstone project. But I want to make an application that would help people plan their vacation. So they could search for and book accommodations, rental cars, plane tickets. They could get recommendations on fun activities and the place they're going, right? So that would be an example of a software specification. Now, it doesn't have to be that grand, that large scale. It could be a game, right? Your software is to be a card game, like a virtual on-the-screen card game. And maybe these days, since people have this social distancing lockdown thing, people are sitting at home and they're lonely, so they could share playing cards on the screen with other players over an internet connection. Whatever, just come up with some project. So you are to specify what your project is intended to do, and then from that specification, do your best. And it's going to seem awkward and clumsy at the beginning, just like the first time you're going to do a unified process implementation in Capstone project with use cases. It always feels awkward when you're doing a new thing for the first time. Yeah, but it's good that you're getting used to it here in class, right, in school. So when you're at work, you'll already be a bit confident with it. So from that specification, what's wrong with 2? Oh, double O. You are to specify what your project's intended to do. From that specification, start to think about your domain and range. What conditions will you handle? What behaviors are you going to deliver? And write them down, make a little table or chart or whatever will convey to me what the idea is. Make some presentation of this in the form of a table, chart, or anything else you can think of that's good. Or anything else you can think of. You're then going, based on your software specification, document, or the software specification portion of your presentation here, based on the software specification part of this presentation document. You and your team are going to come up with what you think will be your software quality metrics. Does your application have to have a high degree of scalability? What about reliability? Right? I mean, it should always be correct. Like, even if you're just playing a card game, I would say correctness is probably always an important one. But if it's a card game, then perhaps availability, say, well, if sometimes the server's not working and they can't play cards, that's not going to kill anybody. But if it's maybe something like somehow life support critical or something very important, maybe you would pay more. Because the thing you're going to learn at work is whatever you want, you have to pay for it, right? You can have 5 nines of reliability, 99.999%. But you're going to pay a lot for it because your service provider has to have many layers of backup. Right? What if there's a power failure in one geography? Then they'll like shift you over to another geography. What if there is an internet failure where you are? Well, maybe they're going to give you a shortwave radio, right? What a lot of companies are doing now after this thing that happened in the States with the pipeline, they're actually getting radio transceivers and radio data links. So even if their local internet service provider goes down, they can get internet connectivity off a satellite. That is very expensive, but if your business demands that, then you're going to pay for it, right? Remember, we have one graph, one chart in our PowerPoint slides where it talks about the availability of the product versus the cost, and it's sort of like a knee curve, right? Like the more you get to 100% availability, it goes up on a parabolic curve, and it really starts getting expensive. Because your service provider is going to have to provision a lot of stuff, right? Technicians, equipment, radio links, backup servers to deal with things that go down. So these are all things you're going to experiment mentally. You're going to do thinking, and you're going to experiment, and you're going to learn how to get comfortable with pushing these concepts around in your brain. All right, let's keep going now. You are to specify. Your project's intended to do. Yeah. So based on these, the software specification in this document, you and your team must now consider what software quality metrics to put into the plan and what requirements to put on those metrics. That's why, actually, I was thinking, because I know last time a lot of students were sort of wrestling, and they were sort of, sending me a lot of questions, illustrating some confusion and so on. So that's why I actually made this right here. And if you do have a printer where you are, print it out. If you don't have a printer, take some paper and actually write it out with your hand. In fact, even if you do have a printer, writing it out by hand is the very best way to learn it. Right? So those are. And I guess if you looked at another book, you might find some other stuff. But I've read most of the good books on software quality engineering, and that's pretty much what everybody says. So you have functional SQM metrics and operational SQM metrics. You have usability metrics, and you have business metrics and structural metrics. So the business metrics relate to cost and people's jobs. We call people resources at work, by the way. You might hear me using that term. You're going to say you need a resource to do SQL programming. That just means you need a skilled SQL programmer. So how many resource people do you need? And there's things that we're not going to get into here. Even in our capstone project, we won't get into it. But at work, I'm just telling you now, they also factor in things like they need real estate, they need an office, desks, phones, support staff. Right? Maybe you have to go out and rent a building or something. Pay for insurance, cleaning. Right? All that stuff is stuff that would go into your business plan. So business attributes reflect the concerns that the business manager has in the development. Actually, here I should have said business manager, I suppose. the boss, the lady or the guy up there at the top who's paying for everything, that the business manager has to develop and evolve the product. So development cost, maintainability, all of these things, you can go and look at your roadmap if you want more definitions of them, or I gave you a PDF of the textbook. So how much do you have to pay each month to keep the product running? If Microsoft puts out a new service patch for Microsoft Windows, your programmers might need to change the base code so it keeps working with Windows. Portability, how easy it is to move to different hardware platforms, iPhone, iOS, Apple Watch, AS400, right? There's dozens and dozens of different hardware platforms out there. Which ones are you going to support? Reusability, that gets to the idea that our code, if it's Java, they say Java's write once, run everywhere. Actually, Java's write once, test everywhere, because even though the Java language specification is the same, different platforms like AS400 is a real son of a bitch, I'm going to tell you. Sorry for swearing, but the AS400 file system is not easy to work with. It goes with a totally different metaphor comparing, because like most of us, I grew up using Windows, right? So can it talk to different hardware, file systems, operating system, API calls, all of that's portability. Reusability is substantially the same as portability, although portability talks about hardware, reusability talks about application-specific things. So if I have a toolkit, right, maybe I made a geotagging toolkit, right? So I made a software application that you could use on an iPhone or a mobile device, which would tell me where the user is right now. So can I take that geotagging toolkit and instead of having it in, because some parents, they put that on their children's phones, right? So they know where the kids are. Well, what if I want to take that geotagging library and now I have workers who are going out into a dangerous situation, maybe a forest fire. I want to know where my workers are, so if they stop answering the phone, I know the last place they were to send the helicopter to go and get them. So reusability is taking a code module and repurposing it to work with another application. Usefulness, which is the extent to which your product is widely needed, and usability is the ease, which means the cost with which it's possible to adapt the product to the requirements of another application or another domain. All of those definitions are in your PDF textbook, and they're all in your roadmap, your Mind Manager map. You can always ask me as well, right? So you want, with your team, maybe if you're a team of 4 people or something, you're going to assign, or assign each team member to go over 1 or 2 of these slides and study it and look for ways to draw those SQMs from that slide into your software test document. So structural, right? So just like business concerns are the business manager, structural concerns are things which primarily the programmers, the DevOps specialists, the database administrators, the people who are putting their hands on the code and making it to work. And once again, I'm not going to read through all of those. Oh, I designed here. Hang on, I forgot something here. Oh, I see, because I was copying and pasting. I guess I copied and pasted some of these a few times too many. So I already said testability once. And high cohesion, low coupling. Yep. All right. Anyway, you can always go back and just check the mind map and see it all there. So structural attributes, support. Yeah, so anyway, go and read through that. So those are our SQMs. You know what your project is. So which SQMs are you going to regard as important for your project? Availability, scalability, calibratability means how easy is it for the user to adjust the parameters of the product to work in the situation they want to work in. So one application there might be, if you're, and one of my students last term did this, was really cool. In Capstone project, She made an API that could go out to a stock market. She found a free stock market API data provider, and she wrote a GUI, and then she wrote in HTML these drop-down boxes, and she calibrated the API, her API, so the user could actually put other stock market symbols in there and track them, and it was tracked in a database. So again, the definition's in your textbook, it's in your mind map, but calibratability is how easy is it to configure the parameters of the product. Interoperability, how easily can your product be made to work with other products. Customizability, maybe things like language. Currency, if you're in different time zones or something. How easy is it to learn? How easy is it to use? Latency, how quickly will it respond? Throughput, how many records or how many gigabytes of data per unit of time can it handle? Efficiency, that's a kind of a theoretical one. We generally don't deal with that too much at school. But efficiency relates to how much work you can get done with a certain number of CPU cycles. That's kind of a mathematical explanation. I'm not going to go into that. Capacity, how many threads or units of work can it handle simultaneously? And scalability, if it's required to suddenly process a bunch more data, can it do it without crashing? And all of that is stuff we talked about a lot yesterday when we were reviewing for the test. But if you guys have questions, right? I'm not sure, since we're not in the class together, I'm really counting on you to reach out and tell me if you have questions or concerns, because I can do a bunch of stuff, but reading minds isn't one of them. So anyway, let's give ourselves another break. We're coming up on the hour, but let's just finish our description of our assignment first. This might take another 5 or 10 minutes, I think. So you're going to present your SSD. You're going to present your test plan. So you're going to think about your test cases. And remember, test cases could be automated with code. They could be a checklist for UAT. Right? It's basically either code testing or manual testing. So, and you know, you can go and read the textbook. They give lots of good examples there. So what are going to be your test cases and test rules? What are going to be your test cases and test rules? And there's good examples in the textbook, as I said there. And now you should specify your oracles. Which is, as we know, are test cases plus the implementation. Could be a checklist, could be a JUnit, could be something else. So oracles are your test rules or cases plus your implementation of how you're going to do that test. How the QA team will deliver on or execute or make it happen, that test. I know my grammar's a little bit stilted, but I'm just trying to over-explain it to kind of get the concept, everybody, right? Make it happen to do the test. Now, these are things we talked about, I think it was last week on Friday or something. So I'm not going to read through them again unless I have questions, right? So a lot of the stuff I say I'm not going to do it unless somebody asks. They say, Peter, could you go through it again? Sure. Or what does so-and-so mean? Well, let me know. But see, these could all be specifications. These can all be examples or implementations of your software quality metrics. Implementations. Software quality metrics. Yeah, what I was saying is, if you have specific questions, you can ask now or later in the Slack room, because I can't really explain sort of every possible graph of things people could wonder about, right? We'd be here for 10 years. But if I get specific questions of something people need more clarification on, then definitely we're going to drill into that. That's all from your textbook. When somebody says the software is a very high quality, well, what dimension of quality, right? So you're going to experiment with the dimensions of quality in your product. I like that. Firuz is a good guy, I think. If I ever meet him, I think I'll tell him, damn it, got him. That's a Persian saying. It means your breath is warm when you want to congratulate somebody for doing something good. If you have any Persian friends, tell them, damn it, got him. All right, so I'm going to actually put that up to here in your learning outcomes. So, turn a hand in. Yeah, I'm going to actually put this in here just because I like that thing so much. Explore the possible dimensions of quality that you can bake into your product. Was that his saying, dimensions of quality? Yeah. Bake into your product. All right, guys, I think I'm going to send us for a break now. We're going till 5:20, and we're going to spend remaining portion of class on JUnit and Mockito, which are coding, right? There's some actual hands-on coding, so that's going to use the other part of our brain because you use, what do they say now? How does this go again? I think you use like the left hemisphere of your brain when you're listening to a lecture, and you use the right hemisphere of your brain when you're going hands-on and doing stuff. So let's exercise the other side of our brain now. So first of all, let me kick this out to make sure everybody has this. And I'm going to put it right up there in your Moodle as well. So save as. Building the test plan. There we go. So if you guys want to go for a break now, I'm just going to kick it up to Moodle, then I'm going to go and take my own break. I have to go and heat up my coffee here. But, where's Dropbox? Why isn't my Dropbox here? Did it crash? No, it's right there. How come I'm not seeing Dropbox? Oh, convert. Oh, copy to psync. This is so strange. Anyway, it doesn't matter. I can put it up in Moodle. Oh, anyway, I've got my Dropbox badge over here. So guys, please let me know if you need more clarification, because even though this is now, I think, our 4th term teaching online, my brain is still oriented to being in the classroom. And if we were in the classroom, I would put you into teams. I get you to start working, then I'd circulate. I'd talk to everybody individually. Well, oh, actually, I've got to close my video too. I think I've answered all my questions here. So let's close my video. I'll upload that when it's ready.